Hi, welcome to this workshop. Today, we are going to explore some basic concept of Anaconda3 and learn how to use it to manage your virtual environment and package installation on your personal computer and use CLI Open to cluster. Anaconda3 is a free distribution of Python, R, and other languages that come with thousands of open sources package and tools for data science. You can easily install and update package and switch between environment inside Anaconda3. We'll use some package example written in Python and C, and both are very popular language for academic research software. But Anaconda3 is able to handle software written in many other languages as well. So let's get started. This paragraph is about the popularity of different programming languages in various domains. It shows the percentage of open source software or package written in each language. While Java and JavaScript are very common for web development, Python is the most popular language overall now. You can tell that C and R are also widely used, especially in data science. So some website and application used every day are written in Python, like Instagram, Spotify, Dropbox, and Reddit. So here, I briefly show you the basic characteristic of Python, C, and R. Python is a powerful language, can be used for many different purposes. Whether you want to do data analysis, simulation, numerical modeling, plotting, or something else, Python can do it. Python is also easy to learn and write. It has a clear and explicit syntax that makes it readable and elegant. If you run the command import this in Python, you will see the Zen or philosophy of Python. The first line says, beautiful is better than ugly. Python used the indentation to structure the code instead of brackets like C or JavaScript. Python has a huge community of users and developers who create and share many packages and libraries. You can just use this ready-to-go package to save time and effort instead of writing your own code. And C language is one of the oldest and the most popular programming language in the world. It was created in Bell Labs in early 70s, based on the previous language called B. C language was used to write the Unix operating system and many other platforms and applications. C language can interact with hardware directory, so usually we use it to write the device driver or system libraries. C language also inspired many other languages like C++, Java, even Python, and Rust. So in the other way, R is a language designed for statistics. It's great for working with data and making plots. For example, you can use R to analyze the medical or biological data and plot the data using the ggplot2 command or function. R has also become more powerful over time. It can do something like numerical analysis or machine learning. You can use R to do the matrix calculation like MATLAB does. And like Python, R also has a tons of packages to choose from. So here, just for your info, if you have any question about this language and software, you can just contact OR computer science group or statistics group for some help. So before we dive into the software, let's understand how it works with different programming language. Basically, there are two types of tools or interface that let us write or run these languages. They are called Integrated Development Environment, IDEs. The first type is text-based, which means you use the terminal to enter the command. This kind of IDE is simple and handy, but not very popular. Many users will find this interface boring because it's just like a black screen with white text. So, and you are not able to use mouse to do anything. If you want to edit your script or code in text mode, typical example ID are Vim, Emacs, or Tmax. Vim is a simple and fast editor, but it has a very limited feature. Emacs is powerful and you can customize it. And in the third one, the tmux, actually tmux is not really an editor, but it's like a terminal multiplexer that allows you to run a multiple session and windows in the same terminal. It also has some advantage over Vim, like it's able to bring your program running on the background and keep your work even when the internet connection drops. So another way of user interface, we call it a graphic user interface, or GUI for short. A GUI lets you to interact with your program using graphic, color, and the button instead of typing command in a terminal. Some examples of GUI for Python are Spider or PyCharm. They are both IDEs that come with Anaconda3. They are very similar, but with difference in some features, like the default library or some plugins. You can use either of them to write or run Python code easily. And C language, actually C language is a kind of low-level language, so there are not much support for GUI. Most of the time we use a text terminal, which is the tmux, Vim, or Emacs to write and run C code. And C++ is a little bit more flexible and can work with some IDE like Microsoft Visual Studio. If you write R language, you might want to use RStudio. It's a nice IDE and you can write R script in a window interface. You can also see your variable and directory in your environment, like file in your home or directories. Another option is R Commander, which is simpler GUI interface for R, but still handy to write the script if you want to learn R. So there are many IDEs that can handle multiple languages. You can write code in Python, R, and even other languages on them. For example, you probably know about the Jupyter project, which includes Jupyter Notebook and Jupyter Lab. Both of them are awesome tools that allow you to write a script, run it, and see the result, even the figures in the same window. You also can save your Jupyter Notebook for a project and share it with others. In the word Jupyter, JU means a programming language, Julia. Py is Python, and R represent R languages. So just to let you know that Julia is a general purpose language, and it is widely used in numerical computation and simulation. You can do all kinds of calculation and analysis with it. It also has the parallel computing feature like MPI. And that lets you run your code on a bunch of the machines at once. It's very useful for big problems such as like climate modeling, chemistry simulation, and even work with huge data. So in addition to those text mode and the GUI interface, one more option is cloud service, like a cloud application. So cloud application are software programs that run on remote server and can be accessed through the web browser or APIs. They offer different benefits like convenience, scalability, security. For example, Google Colab is a cloud application that write and execute Python code in your browser without installing anything on your local machine. All you need is just a Google account and an internet connection. So in our Hopman2 supporting system, user always asks us questions like this. I found some program and package online that I want to use for my research. They are written in a language such as like Python, C, or R. How can I run them on Hopman2? Do I need to install them or compile them from the source code? Well, actually, there are a couple of things you probably need to know. The first thing is Hopman2 is a Linux system. So if the program or package can run on Linux, it should be okay to run on Hopman2. The second thing is some program and package may be already available on Hopman2 cluster as modules. You can just use a command to see what modules are available and load them into your environment. So if a program or package you want to use is not available as a module on Hopman2, you need to install it yourself. You can do it either in your home directory or purchase the project directory. You may need to follow some instruction provided by the author to have it installed correctly. Usually, the installation or the installating software on Linux system require other dependent library and compiler, which means to build a program from the source code, you have to know all kinds of required library and appropriate compiler, and more important, the path where they are saved on the system. Anaconda3 is a shared cluster, but it offers relatively large home space for each user. Every user has about 20 gigabyte space. So usually if the package is widely used for many other users, we can install it on the system. Otherwise, we suggest the user to install package in your home directory. So the package I'm using as a demo are Natural Language Toolkit for Python, same tool for C. NLTK is a package that allows you to do all kinds of things with natural language, like tokening, tagging, or more. And SAMtool is a collection of programs that can help you to process and analyze the sequence data, like sorting, indexing, or converting biological data sets. And the third one, actually, our package are widely used in many fields, like computational biology or data science, even machine learning. However, you don't need to install all of the data all of the package you want to your system, because many of them are already available on the system-wide R module on the Anaconda2 cluster. So, and that's why I don't cover the R package example in this workshop. So before we can use any Python package, we have to do a couple things. First, let's see what Python modules are available on our system. Next, we need to make sure that Python's version we are using is compatible with the program we want to run. Some program only works for a certain version of Python, so you better double check it. Then we can use the pip3 install command to install the package we want. After you log into the Anaconda2, the terminal, you just type module available Python. You will see both the Python 2 and 3 modules. They have some different command. Python 2 is pretty old actually and not supported anymore. So make sure you check the package you need and pick up the right version. We'll recommend the user to use Python 3 unless the package or the developer says something else. Here I want to use the Python 3.9.6, so I just type the module load Python /3.9.6. So to install the NLTK package, we can just use the pip3 install NLTK in the terminal. This command will automatically download and install the package for you. But you see the red text on the screen. It says the regular user does not have permission to write the system folder. So this means you only can install NLTK or any other package in your home directory or your project folder. To check if the package is successfully installed, we can import it and check the version. As you can see here, we import NLTK and it shows the version is 3.8.1, so it works. We can also check the package path to see what is included or inside the package. They are in the hidden folder in your home directory. It's .local/library/python 3.9/site package. You can find the package itself and all dependencies there. So what is dependency? When we use the NLTK, we need some functions that are not part of it. So use the library from other package, and these other packages are called dependencies. You may wonder why not just including everything in the package. Well, if we do so, that will make the package very big and repeat many useful functions. So using those dependencies makes things easier for us. However, you'll also cause the problem with different versions, which we'll talk about later. So, and that's why we prefer to use Anaconda or Anaconda3 for the package management. So next, let's take a look at the C program. To install same tools, first we need to download the source code from the official website using wget. Then you can unzip the file with the tar command. Then you need to compile the code with GCC and Makefile. Make sure you have all the libraries that same tool depends on, like BCF tools and HTS library. So after downloading the latest version of same tool to your home, you can unzip it and the tarboard using the tar command. When we check the same tool folder, is including some key file we need to know. The configure file tells you how to set up the software on your system. The README file has some information what the software does and how to use it. And here is also a Make file. This is a file you can modify for the option to compile the code. So after that, we can just pick up the right GCC compiler and the module to build the code. We run the configuration command to set up software option, and this command will make sure we have the correct compiler path and library we need to build the code. So after configuration, we can just use Mac or Mac install to build the program. And you can also check the executable file in the /bin folder after installation. Here is just one reminder. The executable file only works in the bin folder. If you want to use it anywhere in your home, like a Scratch or project folder, you need to set up the path in your .bash profile. Also, the program needs some specific C libraries to run. So you have to add those C library paths in the bash profile too. So, and actually it's not very hard to install Python or C package using the method I just showed. But just be careful because you could run into some problem with the dependencies if you add more package later on. This means that some package might not work well with others, and you will have to fix them. You have to fix them manually. So let's use the Python example. Think the green box is your Python environment, and it has a basic Python version. Then you install the first package that needs the NumPy 1.13 and SciPy 1.2. And everything works fine with the first package. Then you want to install the second package. However, this second package requires certain version of NumPy, SciPy, and Matplotlib library. So the problem is, in your system, the green box only can store one version of the NumPy or SciPy at one time. So what happens when you install another package that needs a different version of these libraries? Well, and the problem is the new version will overwrite the old one, and that will make the first package crash. So every time if you install the new package, saying we have the package number 3 over here, something else will break. It's like a never-ending cycle of frustration. So how can we fix it? Usually the regular installation of Python is not able to fix it. We have to use the virtual environment. That's why we use the Anaconda as a solution. So besides the independence problem, we might face other challenges when we install or running the software on HPC cluster like Hoppin2 cluster. For example, what if Python or R version changes? Can we deal with that? Or do we have to know all the dependencies we need? What if we need a package that's written in some language even we don't know? How can we use it? And actually, Anaconda is a great tool, not only for data science and machine learning. It also helps you to manage your package, environment, and dependencies in a simple way. You can use Anaconda to access various applications like Jupyter Notebook, Spider, and RStudio we just talked about. This application lets you write, run, and debug your code easily. Excuse me. With Anaconda, you can just focus on data science or data analysis without worrying about the technical detail. So what is Anaconda? Anaconda is more than just a bunch of Python packages. It started with a large collection of Python tools, but later it expanded to many other languages. Anaconda also offers management and service features that make life easier for both developer and the user. Anaconda has four main features: additions, navigator, cloud, and Conda. Additions are different versions of Anaconda for different needs and budget. Only individual addition is free. Navigator is a graphic interface that allows you to access the various tools and IDEs. Cloud is a space where you can store and share your package and projects online. And the last, Conda is a tool and management tool that help you to manage your package and environment easily. So you probably heard about Anaconda and Miniconda. Actually, both are awesome tools for managing Python package and environment. But what's the difference between them? Anaconda is like a big bundle of everything you need for data science and machine learning. It comes with Python and over 1,000 packages already installed. It also has a cool GUI called Navigator. And so you can, from the Navigator, you can launch application like Jupyter Notebook or Spider and just to use it on browser. Miniconda, on the other hand, is a kind of more minimal. It only has a Conda and Python and few other packages. You have to install the package you want manually, but it's also faster and takes much less space. So it depends on your preferences and need. Anaconda is good if you want a convenient software, and Miniconda is good if you want more flexible and more control. So if you want to use Anaconda or Miniconda on your computer, just follow some simple steps for an easy installation. First, visit the official website and choose the right file for your operation system. Windows user can just download an exe file, and Mac or Linux user, please just get a bash file. Then open a terminal and run the bash file. That's it. So next step is get the Conda ready. Pick up your shell and type Conda init, which is initial with it. For example, I'm using a bash shell, so this command will change my bash rc file, so I can use Anaconda or Conda command whenever I log in. So next, let's talk about the Anaconda Navigator. It's a pretty handy tool that lets you manage your package and environment without using the command line. You can launch it from the menu if you have Windows, or from the terminal if you use Linux or Mac. So in the terminal, you just simply type Anaconda-Navigator and hit enter. You will see a dashboard with a different option. You can have the Jupyter Notebook, Jupyter Lab, or Spider to write Python or run Python. You can have Orange for data mining. You also can have the RStudio to run our code. So just click the icon, you are ready to go. So this basic environment is only one you have right now after you install the fresh version of Anaconda. However, you can create more environment if you want. Conda virtual environment is like a separate box where you can store different versions and different libraries. In this base environment, you can see the list of all libraries and their versions. So with Anaconda, you also can access the online resources to learn something very interesting and helpful packaging. For example, like Pandas. Pandas let you do the analysis easily. NumPy help you to work with array and matrix. SciPy allows you to perform complex calculation. And Anaconda also support some graphic and visualization libraries, something like Mapra library or Bucket. The last component is Anaconda Cloud. Anaconda Cloud is a very important cloud service that's including a lot of packages from different purposes. So you can search and download the package you need from Anaconda Cloud. It also helps you to manage your package and keep everything updated. Think Anaconda Cloud is like a big TV with many channels. Each channel has different program and package. You can switch between channel to find the package you need. Some package might be available in more than one channel, but others might be just exclusive for specific channel. So that's why we need to be specify the channel name when you install a package. And a channel is like a repository of packages. The most common one is Anaconda, and which included the essential package for data science. But there are also other packages specialized in a certain domain or framework. For example, Bioconda. Bioconda has a package for bioinformatics like DNA or RNA analysis. PyTorch has a package for deep learning using PyTorch. And CondaForge has a package for scientific computing and other domains. And of course, like our channel has a lot of package for our programming. So think of the Conda, the management tool, is your personal lift truck. You can go to the Anaconda Cloud and pick up the package you need from the right channel, and we'll back the package back to you and install for you automatically. So Conda, you can also use the Conda to keep every package up to date. So in this workshop, we have known some basic concept of Anaconda3 and its main feature. So in the next part, we'll dive into the virtual environment and run real cases with Anaconda commands. Thank you.